Okay, so the last question is a connected particles question. Two particles A and B of masses m and km respectively are connected by a light inextensible string, so that's important, and it passes over a smooth fixed pulley. And then when the system is released from rest, blah blah blah, A is going accelerating up, A equals a quarter g meters per second squared. And that means that B is going to be accelerating down with the same acceleration, a quarter g meters per second squared. Okay, the reason they're accelerating at the same rate is because of this light inextensible string. It's because it's inextensible that they're going, everything they do, they have to do the same. So if B moves down 0.5, then A is going to move up 0.5. They have to do the same thing because they're connected by this thing that's inextensible. Now, some people said stuff about the pulley. To be honest, in the exam, just write down loads of stuff, like all of these assumptions. If you're not sure, just write them all down. Because inextensible is the thing that means they're moving at the same speed, acceleration, distance covered, etc. But if you're not sure, then you could write inextensible string means blah blah blah, smooth pulley means blah blah blah. It's better to put too much rather than too little. So that's how. So your 2 marks, well, one is for getting the right direction and this acceleration, and the other is for explaining why the inextensible string means that. Okay, and then you're asked to find the value of k. So I'm just going to add. So you would have to draw your own little drawing, but I'm just going to add forces on here. We've got mg and t going up. And we've got T here as well, and a KMG. Okay, so then resolving going up. So this is for particle A. We've got T minus mg equals ma. Okay, that's because we know it's going up. The resultant force is everything that's going up, which is T, minus everything going down, which is mg, and by Newton's second law, that's equal to ma. Okay, now resolving going down for particle B, so everything going down is kmg, and everything going up is t, so kmg minus t, because it's going down, equals kma. Right, now we can add these together, and we get kmg minus mg, because the t's are going to cancel, and that's equal to ma plus kma. Now we can cancel all these m's, and then we'll get kg minus g equals, let's put in a as well because we know that, a quarter g plus k times 1/4 g. Okay, we can cancel all these g's as well, and then we've got k minus 1 equals a quarter 1 plus k. So 4k take 1, this is multiplying both sides by 4, equals 1 plus k. Therefore 3k, taking k from both sides, equals 5, adding 4 to both sides, therefore k equals 5 over 3. Okay, now part C, we want to calculate, well, given that A does not hit the pulley, calculate the speed with which B hits the ground. So basically we look back and it says they're released from rest, okay, so U is 0. And V is what we're looking for, and then it's 0.5 meters, this little distance here. So I haven't written that very big, but 0.5 meters to the ground, so S equals 0.5, and we know the acceleration, which is a quarter g. So we use V squared equals U squared plus 2AS. So V squared equals 0 squared plus 2 times a quarter g times a half, which is 2 times quarter g times half, and that's just a quarter g, which is 2.45, and then so V, we take the square root of 2.45, and we get 1.565, which is 1.57 to 3 sig figs, or 1.6 to 2 SF, and our units are ms to the minus 1.